Let's look through the multiple choice questions on the most recent chemistry exam. Number one, we're looking for the oxidation numbers of oxygen and nitrogen in the nitrite ion. Now, we know that oxygen is always going to be -2 unless it's in peroxide. So that's a given. That allows us to write a little brief algebra problem that says that nitrogen plus 2 of the oxygens at -2 each give us a total charge of -1, and when we solve for nitrogen we get +3. So that gives us -2, or 2 minus and 3 positive. So that allows our choice for the first one to be number D. Let's see if we can make that a little bit bigger. Maybe not quite that big. There we go. All right. Number 2, a 16.4 gram sample of HF is dissolved in water to give 200 milliliters of solution. What is my concentration? Well, to get that we need the number of moles. So we say 16.4 grams divided by 20 grams per mole gives us approximately 0.8 moles. And we're going to divide that by 0.2 liters, and so we can tell that that's going to be equal to a number that is approximately equal to, let's see, here we go, approximately equal to 4, and in fact it's 16.4 is slightly greater than 16, which would have given us 0.8, so we're looking for a number that's slightly larger than 4, and we can see that the only answer that makes any sense is choice D. So we're going to go with choice D. All right, we move on to the next one. Number 3, a solution is prepared by combining 100 milliliters of 0.2 molar sodium sulfate with 100 milliliters of half molar potassium sulfate. We want to arrange these ions in order of increasing concentration. So we can see that we're going to end up with, when we look at this, we're going to end up with, when we look at this guy right here, we're going to end up with 100 millimoles of potassium. So 100 millimoles of potassium and 50 millimoles of SO4. And when we look at this guy right up here, we see that we're going to end up with 40 millimoles of sodium and 20 millimoles of sulfate. So when we add all that up together, we end up with 40 of sodium, 70 of sulfate, and 100 of potassium, and that leaves us with our answer of choice B when we rank them in the correct order. All right, let's move on to number 4 on this first page. Which of the following aqueous solutions contain the greatest number of ions? Okay. Well, we can look at the first one, and I can see that I'm going to have 40 of sodium and 40 of chloride. That gives me a total of 80. When I look at the second one, I can see that I'm going to end up with 30 millimoles of calcium and 60 millimoles of chloride. That gives me a total of 90. That gives me 90 for the second one. When I look at the third one, I'm going to end up with 20 of iron and 60 of chloride. That gives me 80 for the third one. And the fourth one, I'm going to end up with 20 of potassium and 20 for bromide, which gives me a total of 40. Therefore, the one with the largest number of ions, which will be choice B. All right, looking at number 5, what volume of 18 molar sulfuric must be used to prep 2.3 liters of 0.145 molar? We use our equation that says V1M1 equals V2M2. And when we solve all of this, we get 19 milliliters. That gives us a choice of A, a very easy problem. Number 6 isn't really more difficult. In fact, we just have to compute moles. We know that molarity is equal to moles divided by volume. So I can rearrange that to solve for moles, because moles is equal to molarity times volume. And when I solve for that, I get 2.79 times 10 to the minus 4th moles. And that's very, very close to choice C, 0.0028, given the right number of sig figs. Problem number 7. How many grams of glucose are present in 500 milliliters of a 0.5 molar glucose solution? Again, we want to solve for moles, so we know that moles are equal to M times V, and I can plug everything in, but now I've got to multiply by the formula weight for glucose, which they give us, and I get a number that is approximately 45 grams, give or take a little bit of sig fig issues with the formula weight. You don't really have to worry about a calculator. You can approximate 180, and 0.5 times 0.5 would be a quarter of 180. Well, half of 180 is 90, and half of that would be 45. And that gives us our answer for the third one. And then we take a look at number 8. We want to compute what volume of solvent has evaporated. And when we do that, we can use M1 V1 is equal to M2 V2. And we can solve for V2. In this case, what we get is V2 is equal to 49 milliliters. Well, if we have V2 is 49 milliliters and we started with 230, then our answer must be 181 milliliters. So that would be choice C.